In this short video, we'll talk about the addressing mode. This is an example load instruction. In this example, register R0 holds the base memory address. We can also use an immediate number called offset in the load instructions. Here we have 3 different load instructions. Each of them contains an immediate number 4. This immediate number is also called offset. The range of offset is from -255 to 255. These instructions use 3 different addressing modes, including pre-index, post-index, and pre-index with update. This gives an example of a pre-index. Suppose register R0 holds the memory address 20000 in hex. The target memory address equals to the base memory address plus the offset 4. Then, we read the word from the target memory address. The value of register R0 remains unchanged. This is a summary of the pre-index operations. This is an example of post-index. For post-index, the value is loaded from the address in the base register R0, and then is saved into register R1. In addition, the offset is added to the base memory address. This is an example of a post-index. For post-index, the value is loaded from the address in base register R0, and then it's saved into the destination register R1. In addition, the offset is added to the base register. Accordingly, the value of base register R0 is incremented by 4. This is a summary of the post-index operations. This is an example of a pre-index with update. We can recognize this mode by the exclamation mark at the end of this instruction. It's very similar to pre-index. The only difference is that the base register R0 is incremented by 4 in this addressing mode. This is a summary of the pre-index with update. In sum, we have 3 different addressing modes. In pre-index, the target memory address is the base register plus offset. In post-index, the target memory address is the base register. After the word is loaded from the target memory address, the base register is incremented by the offset. In pre-index with update, the target memory address is the base register plus the offset, and the base register is also increased. Now, let's check your understanding of addressing modes. Assume little endian is used. Register R0 and R1 have these initial values. Given a short assembly program that consists of 3 store instructions, shows memory contents when the program completes. You can pause the video now and start to work on the solutions. Here are the solutions. The first instruction has the exclamation mark at the end, therefore it's a pre-index with update. It first increases the base register R0 by the offset, and then writes the value of register R1 to this memory location, and finally modifies the base register R0. The second store instruction is post-index. It first stores the word to the base address, and then increases the base register R0 by 4. The last instruction uses pre-index. Note that this is strh, not str. It stores a half word, that's the lower 16 bits of register R1 to the target memory location. The target address is the base register plus 4. This instruction does not modify the base register R0.